Hello everyone and welcome to another tutorial on empirical and molecular formulae. This is the objective which is highlighted in the syllabus. It says to calculate this formula given the appropriate data. The data is about the same in every other question in the past papers. So in order to get a good hold on this topic, you would be practicing more questions and can attempt these questions better. The empirical formula shows the simplest whole number ratio of the different atoms or ions in a compound. So this whole number ratio is similar to what you do in mathematics, like you make a fraction in simplest terms by dividing with a common number. So for example, if there's a formula given C3H6 and they ask you to derive the empirical formula, so you can see that 1 is 3, 1 is 6. So as you do in fraction, 3 over 6, 3 upon 6, so that becomes 1 upon 2. That is the ratio is 1 is to 2. So so the simplest would be CH2 because 3 is to 6 can also be written as 1 is to 2 by dividing both this 3 and 6 by 3. This is as you have done in mathematics. Also, if you put it directly in a scientific calculator, you are going to get this ratio easily. Similarly, if the compound given to you is like C6H6, so you can see it's 6 and 6. So 6 over 6, the ratio is 1 over 1. So that the empirical formula would become CH. Similarly, another example, if it is C3H18, if you know, when you will put this in the calculator 3 over 18, it can't be simplified further. It would return to you 3 over 18. So it is already in its simplest term. So the empirical formula would be same as C3H18. So this was about empirical formula. As for the molecular formula, it shows the actual number of atoms which are combining to form a molecule of a compound. So molecular formula shows the actual number of the different atoms of the elements in that particular compound, while empirical formula is by showing the simplest ratio for that. So we can say that these are the molecular formula for these particular compounds, and when we simplify them to the simplest ratio, this becomes the empirical formula. So this is an example of a question from the past papers, which is similar to many other questions which come up. So it says that there's a compound containing 70% by mass of iron, 30% by mass of oxygen, and you have to derive the empirical formula. So if they have not given you the masses in terms of gram, they're given you in terms of percentage. So you have to assume that the percentages are as like masses given out of 100. You know that percent means out of 100. So 70% of iron, we can also say that it's about like 70 grams of iron out of 100 grams of whatever this whole compound is, which we are going to find out. So iron is combining in 70 grams while the oxygen is 30%. So we can say that out of 100 grams, this would be 30 grams. So we can say that oxygen is 30 grams. Next is that we are going to find out the moles. Okay, here some headings are given. So you can always try this out, that whenever you're going to practice a question in your actual paper too, just make headings like this in the space given and put on top those elements which are given in the question, which may be 2 or 3 or 4, any number like this. And then you start filling out this middle part and you will get the empirical formula in the end. So for the moles, now you're going to calculate the moles by doing mass over AR of that particular element, which is also given over here. If not, you can find in the periodic table. The moles would be 70 for over the AR for iron, as given in the question 2 is 56. For oxygen is 30 over 16 is the AR. So therefore, the number of moles that would come up to be is yeah 1.25 and 1.875. Next, that you have to find out the moles ratio. So ratio, as I already before told you, is just like you do it fraction, you divide it. So this would approximately come to be 1 over 1.5, and putting this into whole numbers that we don't want it in decimal form, that would come out to be over 2 over 3. So the molar ratio came to be 2 over 3. Also, if you put this thing directly into your scientific calculator, you will be directly getting this ratio. So you can see that there are 2 for iron and 3 for oxygen. We kept iron at the top and oxygen on the below. So 2/3, Fe2 and O becomes 3. So the empirical formula is Fe2O3. And we are done over here. So the answer comes to be B. Next, we are going to move on to the molecular formula. So I've taken a different example for the molecular formula because over here we were getting an ionic compound, and ionic compound does not have a molecular formula. The formula of an ionic compound is same as its empirical formula. This would be clear in the chapter on formulae, so not going into discussion right now. For molecular formula, I've taken an example that there's some empirical formula given as C4H9, and the MR is 114 of that particular compound, the molecular formula for which you have to calculate. So there are 2 steps for this. Again, you have to practice and just remember these 2 steps. So N is given by MR over the empirical mass. So N would be equals, the MR given in the question is 114, and empirical mass is actually the mass which is derived from the empirical formula given, which is C4H9, just like you calculate the MR from the periodic table. So for the C4H9, you are going to refer to the periodic table and find the empirical mass. That is 4 atoms of carbon, so it would be 4 multiplied by 12, which is the AR of carbon, plus 9 atoms of hydrogen, and the AR is 1. So this would come to be 57, and this would, therefore, the N comes to be 2. So this was step number 1, in which you find uh, a, a number known as N, and then you have to multiply this empirical formula by N. That is, the C4H9 would be multiplied by N. So the step over here is you're going to do N multiplied by empirical formula, which is C4H9, which over here is N is 2 multiplied by C4H9. So this 2 is going to be multiplied by both the numbers of both elements, that is by 4 and 9. So therefore it would come out to be 4 2s are is 8 and H is 18. So this comes out to be your molecular formula. And this was the empirical formula, which is given in the question, is the simplest form. If you do 8/18, you are going to get 4/9. So this is it for uh, empirical and molecular formula. The thing is that practice it, keep a similar strategy and a similar approach every time you practice it, and you are never going to get it wrong. So that's it, and thank you.